Listen, there is a tiny, almost invisible mistake regarding software choices that is literally costing thousands of students massive marks in the Cambridge IT 9626 exam every single year. You memorize the textbook, you know all the definitions, you sit down to write your answer, and boom, you drop a crucial grade boundary. Why? Because just knowing the facts is only half the battle. How you structure those facts is the whole game. So let's dive into this explainer and fix that exact mistake right now.
Okay, take a look at this classic, flawed student answer. Custom software is good because it fits. Off the shelf is cheaper but has bugs. Now, to an untrained eye, it doesn't look terrible. The statements are technically true based on the syllabus, but in a high-stakes exam environment, this kind of ordinary fact listing is going to completely fail you. Let's break down exactly why this drops the ball.
Here is the brutal reality of the examiner feedback. This answer simply lists basic facts with absolutely zero depth. It entirely lacks the explanation of why a feature actually matters to a business. It completely fails to link the points together, and it misses the final judgment entirely. Honestly, if you write like this, you're leaving the examiner to do all the heavy lifting, and they absolutely will not give you top band marks for that.
So, we need a solution. Let's introduce the Peel Answer Framework.
The secret here isn't studying harder, right? It's structuring smarter. We have to completely transform our approach. Enter the Peel Answer Framework. This is the structural goldmine that examiners are desperately searching for. Step 1, the point. Just state your main idea clearly. Step 2, evidence. Back it up with a specific syllabus-approved fact. Step 3, explanation. Okay, this is where the money is. Describe exactly why this fact matters in context. And step 4, link or judgment. Connect it right back to the core of the question. Now, in just a minute, I'm going to show you the ultimate examiner clue that changes your answer completely. But first, you need to see how to apply this framework to the actual software types so that clue makes sense.
Let's start by analyzing off-the-shelf software. Now that we have our framework, we need raw material to feed into it. We're pulling directly from our source material on software types. First things first, let's get the definition locked in. Off-the-shelf software is pre-existing software that is available straight away and ready for use by individuals or organizations. Think of your standard word processors or, web design packages. It already exists. But, as we'll see, that convenience comes with some pretty major compromises.
By the way, setting up your study notes using comparison tables is the absolute best way to make sure you're gathering specific evidence for both the pros and the cons. It's like a giant puzzle, and tables organize the pieces. Let's extract the key data right now for our PEL answers. So what's the hard evidence here? On cost, off-the-shelf is a huge advantage because it's cheaper. Multiple customers share those development costs. But the disadvantage? You might end up paying for massive, complex features you don't even need. For availability, yeah, it's instant, but adapting it to a company's specific system might eat up huge amounts of storage space. And regarding support, you get massive internet forums and telephone helplines, but the core settings of the software itself, they might be totally locked and unchangeable.
All right, let's do a quick test of your focus. I want you to spot the error in this statement. Off-the-shelf software is completely bug-free because it is mass-produced. Think about this for a second. If you wrote that exact sentence in your exam as evidence, do you think the examiner would give you the mark? If you said no, you hit the nail on the head. The reality of software testing is way more nuanced. Our source tells us that off-the-shelf software is usually tested rigorously. It's been used many times by other people, meaning most bugs have already been discovered and removed. It is highly unlikely to have bugs, but stating it is 100% completely bug-free, that is a massive trap. Nothing is guaranteed to be entirely flawless, and absolute statements like that will cost you marks for sure.
Moving right along to evaluating custom-written software. The crucial point is knowing the exact phrasing from the syllabus. Let's flip the script and evaluate the alternative. By definition, custom-written software is specially written for a particular task and developed for a specific organization or individual. This means it requires specialist programming skills, whether you're building a unique database or a highly specialized stock control system. Pulling from our source material again, let's look at the evidence for custom software. The biggest advantage? Fit. It meets all customer requirements exactly and integrates perfectly with current systems without any awkward adaptations. Plus, the original programmer is readily available to make changes. But to massive downside, it is incredibly expensive to pay a programmer from scratch, and development takes a really long time. Also, relying on a small team means if that programmer leaves, you might have literally zero support left.
Now, what's genuinely fascinating here is the bug comparison, because it's often the exact opposite of what students intuitively think.
Custom software can actually have more bugs initially. Why? Because it hasn't been tested thoroughly by thousands of people. The programmer only tests it based on how they expect it to be used, which might not match the messy real world. Off-the-shelf, on the other hand, is rigorously tested by the masses.
And here is another brilliant piece of evidence to secure those top marks. Copyright. With custom-written software, the customer actually owns the copyright once it's built. That means they can legally sell it to others for extra income. With off-the-shelf, even if you adapt it for your business, you absolutely cannot sell it without infringing on the massive software company's copyright. It's an incredible evaluation point to keep in your back pocket.
All right, it's time for the top band transformation.
Okay, we have all the raw materials. We understand the testing, the costs, the copyright, the definitions, the whole shebang. Now, let's bring it all together. Look at the power of this transformation. On the top, we have that flawed answer again. Custom software fits better. It's just so weak. Now look at the top band PO version. Custom software meets all requirements. That's our clear point. As programmers tailor it to the system, there is our solid syllabus evidence. Eliminating unnecessary features found in off-the-shelf options, boom, that is our explanation of why it matters. This is exactly what the examiner wants to see.
So here is a challenge just for you. Pause right here and mentally, or on paper if you want, write a final linking judgment, comparing the long-term support of custom versus off-the-shelf software, using the evidence we just went over. Think about the small programming team leaving versus those vast internet forums. Getting this step right, that is how you cross that threshold into the highest possible grade band.
And that brings us to the missing examiner clue. All right, assuming you've got the Peel framework locked in, you are now equipped to handle 90% of evaluation questions flawlessly. But there is one final, critical trap. Everything we just did was to evaluate. What if the command word on your exam paper asked you to analyze instead? If you write a Peel evaluation for an analysis question, your perfectly structured answer will hit a hard ceiling on the mark scheme. Command words are the invisible strings controlling your grade. To find out exactly how command words decide your mark band, you need to click the video on your screen right now. And make sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that video and I'll see you over there.